Hello and welcome to our webinar on Next Generation Power Protection for Data Centers. I am Adam Koshel, Power Protection Business Manager at ABB, joined by my colleagues Justin Lucas, Power Protection Product Manager, and Tomasz Szabo, Power Protection Sales Manager. Together, we will explore the innovative solutions offered by ABB Power Protection, ensuring dependable power supply through the use of ABB's HiPerGuard Medium-Voltage UPS. First up, let's discuss ABB's power protection and its significance in critical applications. ABB Power Protection has an extensive global presence with 900 employees across 20 countries. Our research and development centres in Switzerland, New Zealand and the US, along with production facilities in multiple countries, enable us to provide cutting-edge solutions worldwide. Our business offerings encompass a wide range, including commercial and industrial UPS, power conditioning products, static transfer switches, and power distribution. We adopt a multi-channel approach, collaborating with OEMs, system integrators, EPCs, distributors, and more. ABB's Power Conditioning Centre of Excellence in Napier, New Zealand, is the third and final facility in the power protection portfolio. It provides multiple operations as well as research and development test cells for power conditioning and energy storage system products. The Napier facility has large capacity load banks, VRLA and lithium-ion battery banks, as well as our SAG generator, which enables us to simulate various power quality events, including sags and surges, enabling our high-power product portfolio to be put through its paces inside this world-class R&D test facility. Please join me in watching this short video on our Napier Power Conditioning Centre of Excellence.
This is a power conditioner made by our team here at ABB. You might ask, what is a power conditioner? Power from the grid isn't always stable. Outages and voltage sags can cause equipment to malfunction, resulting in lost production and even equipment damage. This is an issue for modern factories, or anything that relies on uninterrupted power. Our power conditioners create a stable, clean supply of power, free of outages and sags.
With more people on the planet, there are bigger factories, more machinery, more automation, more need for our innovative mindset.
We challenge the status quo to help factories around the world safely and efficiently create the things that surround us every day.
From mobile phones to fast cars.
From microchips to super yachts.
From bottles to beverages.
From research labs to stadiums.
From a startup company with a dream to a purpose-built state-of-the-art ABB factory.
So, how do we do what we do?
We are curious, always believing there is a better way.
We care about our customers, our people and the environment.
We collaborate to get the best results for our customers.
We have courage to take action and speak up.
We are researchers and designers.
We are organizers and prioritizers.
We're assemblers.
We're problem solvers.
We are engineers.
We are testers.
We're dispatchers.
We are one team, making the world a better, more sustainable, more efficient place to live. Let's write the future of safe, smart, sustainable electrification together.
ABB excels in designing and manufacturing power protection products, including the PCS100 UPSI, HiPerGuard MV UPS, active voltage conditioners, static frequency converters, and our energy storage systems. These solutions find applications in 24/7 operations and critical processes across industries such as data centers, food and beverage, semiconductor manufacturers, water treatment, pharmaceuticals, and much more. Data centers are already significant in relative energy storage capacity. Can they do more for the grid? Introducing ABB's HiPerGuard MV UPS, the next generation power protection for data centers. The shift from low voltage to medium voltage represents a natural evolution in the power protection for substantial critical power facilities. A key advantage lies in significantly lowering costs associated with facility construction and operation. This is achieved through larger protected load blocks, a reduced switchgear count, and minimised size of busways and cabling, resulting in lower losses and higher overall efficiency. Now I'm pleased to introduce our expert, Justin, who will guide us through the intricate details of the HiPerGuard MV UPS.
Thanks, Adam. ABB's industry-first medium-voltage UPS provides continuous and reliable power supply up to 24 kilovolts, intended for multi-megawatt power protection. ABB's ZISC, Impedance Isolated Static Converter, is a high-performance power conditioning and uninterruptible power supply architecture. Based on an isolating line reactor paired with advanced ABB power converters, this simple yet robust design ensures unmatched reliability and efficiency. The ZISC architecture operates independently from the utility, continuously conditioning and filtering line disturbances, voltage imbalances, and addressing load-related events with high overload capability. Positioning at medium voltage, the isolating line reactor and coupling transformer simplify maintenance, while the power converters and energy storage operate at low voltage. The HiPerGuard's 2.5 MVA system output prioritizes redundancy through ABB's modular approach, allowing seamless operation even with 1, 2, or 3 inactive modules. Paired with modern energy storage, the HiPerGuard provides autonomies ranging from seconds to minutes, making it a versatile solution for critical facilities. For a closer look, let's check out our introductory video.
Now more than ever, the demand for processing and storing data is increasing exponentially. Data centers are growing their infrastructure to meet demand. They are also trying to adhere to sustainability paradigms and are trying to reduce their carbon footprint. ABB's HiPerGuard tackles these challenges, providing continuous high-capacity power for critical industries, including data centers, and is designed to protect entire facilities, whilst reducing carbon emissions by several hundred tons. HiPerGuard provides the opportunity to create additional revenue streams through grid support capabilities, including demand response, whilst contributing to overall grid stability and reliability. With data center downtime estimated up to $1 million per event, the demand for continuous and reliable power continues to increase. ABB's HiPerGuard minimizes downtime by tackling modern power quality issues, preventing data processing errors, equipment failures, and overheating by protecting from voltage sags, swells and spikes, and power interruptions. HiPerGuard combines the best of traditional dynamic rotary systems and static converter technology to deliver a robust and reliable medium voltage UPS that achieves superior performance. ABB's HiPerGuard is not just a product, but a turnkey high power protection solution. ABB has made power protection easy. Let's write the future of safe, smart, and sustainable electrification together.
You may now wonder what a HiPerGuard MV UPS actually is. In this slide, we can see the main components that make up the HiPerGuard MV UPS. At the top, we have the external MV switchgear and control. In the MV section of the UPS, we have the isolating line reactor and the coupling transformer. Conversely, the power electronics and the system control lie in the LV section of the UPS, which in turn is connected to the energy storage. The main purpose of the HiPerGuard is to supply perfectly balanced three-phase voltage to the load, whilst assuring that the load's active power requirements are provided by the utility. Let's walk through the HiPerGuard startup process. Operation of the MV switchgear is controlled by the HiPerGuard's Graphical Display Module, GDM, and system controller. With a simple command, the auto bypass breaker closes, allowing power to flow from the grid to the load. The HiPerGuard then starts the synchronization process, aligning its output voltage in phase with the grid, while keeping the load powered by the grid. Once in sync, the input breaker closes with the load still powered through the auto bypass breaker as the low impedance path. Finally, the auto bypass breaker opens, directing the current through the HiPerGuard MV UPS. Initially, the phase shift between input and output being 0, gradually adjusting this phase shift to 30 degrees, with the start process now complete and the unit now operating in power conditioning mode. This whole process takes less than 1 second with full load. In power conditioning mode, the HiPerGuard will inject or absorb reactive power into or from the load to keep the voltage at 100%. The HiPerGuard changes the angle between the grid and the output voltage to absorb or inject reactive power into the system. During this action, there is no significant energy storage cycling. During power conditioning mode, the main purpose of the UPS is to supply perfectly balanced 3-phase voltage to the load, whilst assuring that the load's active power requirements are provided by the utility. This is achieved by controlling the voltage angle across the reactor, making PS equal to the load's active power requirements. This assures you that no energy storage is used during this mode, and the energy is saved to be used when the utility is further out of specification. This graph here shows how the input breaker is managed. The time it takes to switch between independent mode depends on the input voltage. The deeper the sag, the quicker the switch. The HiPerGuard can stay in power conditioning mode for an extended time if the input voltage remains between 85% and 115% of the nominal. For voltages between 90% and 85%, the UPS is ready for transition, reducing the phase shift. If the voltage drops below 85%, the HiPerGuard syncs to the grid and quickly opens the input breaker. The MV breaker takes about 70 milliseconds to open. Impressively, the HiPerGuard will remain in power conditioning mode for 1 second, even with the nominal input voltage sag of 50%. After the transition to independent mode, the load is fed by energy stored in the batteries. The autonomy will depend on the load level and the battery sizing. This can span from seconds to several minutes. The HiPerGuard stands out by surpassing the IEC 62040-3 Class 1 industry standard. This not only provides electrical designers with ample engineering margin, but also ensures safe headroom for voltage drops between MV output and LV loads. Examining the performance depicted in the dark grey zone on the graph reveals the HiPerGuard's output voltage over time during changes in operation mode and load steps. Highlighting its robustness, the HiPerGuard boasts an impressive short-circuit current capability in power conditioning mode. It handles 460% overload for 2 seconds, while in independent mode it maintains a remarkable 3.6 times nominal capacity for 2 seconds, using the inverter only. These figures underscore the HiPerGuard's reliability and strength across various operational scenarios. Here we see the HiPerGuard's dynamic performance during reduced capacity mode, with only 12 out of 18 250 kilowatt power electronic building blocks (PEBs) in operation. Here we see an overhead view of a single 2.5 MVA HiPerGuard unit. Various components contained within each enclosure play a critical role. The DC termination enclosure, DCT, retains the cable connections for the energy storage. The auxiliary power supply enclosure, APS, contains the redundant power supply modules for the system command and control. The MVM, medium voltage magnetics enclosure, houses the coupling transformer and isolating line reactor. There are 3 power electronic enclosures incorporating a total of 18 PEBs. In this view, we can now see detail more clearly of the HiPerGuard's internal components. Each of the PE120 platform enclosures contains 6 PEBs. The first with the main controller and the graphics display module. We can also see the magnetics enclosure, containing the medium voltage isolating line reactor and coupling transformer. Now, Adam will navigate us through the key considerations and best practices in ensuring the seamless integration and longevity of ABB's HiPerGuard MV UPS. Adam, the floor is yours.
Thanks, Justin. The HiPerGuard MV UPS is designed with long-term system availability in mind, due to the modular power electronic building blocks and superior design concepts, delivering time and cost savings for maintenance teams. ABB's lifecycle management model maximises the value of the equipment and the maintenance investment by maintaining high availability, eliminating unplanned repair costs and extending the lifetime of the system. The PCS120 PEB is a horizontal draw-style pluggable module designed for three-phase pure sine wave power conversion, each rated at 250 kVA and 480 volts. This means maintenance from installation to 9 years is only needed to be performed at low voltage. Therefore, intrusive system maintenance is only required once every 10 years. When it comes to the HiPerGuard MV UPS, key features include advanced control and diagnostics, seamless fibre optic internal communication, and enhanced service logs for comprehensive oversight. Additionally, it offers easy-to-access maintenance parts, efficient cooling with dedicated fans, and withdrawable construction for convenient maintenance with a mean time to repair of less than 15 minutes. These features collectively ensure the reliability and ease of maintenance of the HiPerGuard MV UPS. Now we delve into the sustainability aspect of ABB's HiPerGuard MV UPS. Tamash, our speaker, will guide you through this part of the webinar. Tamash, over to you.
Thank you, Adam and Justin. And now I'd like to outline ABB's commitment to environmental sustainability. At ABB, we actively promote transparency and sustainability throughout our operations. ABB's electrification smart power business is a key player in the global electrification and energy transition. 35% of global sales now involve products with both an independent environmental product declaration, EPD, and ABB's Eco-Solution label. This value continues to grow year on year at a rapid rate. By 2025, 80% of ABB Smart Power's revenue will come from the technologies and solutions with EPDs and Eco-Solution labels. To qualify, an ABB Eco-Solution must demonstrate sustainability in its design, sourcing, operations, packaging, logistics, and energy efficiency during usage, along with a responsible plan for end-of-life, take-back, or recycling. These independent EPDs are rigorously audited by third parties to ensure environmental accuracy. The ABB Eco-Solution label provides full transparency on a product's circulatory value and environmental impact. We are proud to promote that our HiPerGuard Medium-Voltage UPS upholds this Eco-Solution certification label. For our customers, the ABB Eco-Solutions label is a guarantee that when relevant, the product they are purchasing is designed to last and is manufactured with the maximum amount of sustainably sourced raw materials. It's crafted with processes meant to minimize waste and maximize the use of sustainable packaging materials. These products are designed to enhance resources and process efficiency during usage, be upgradable, and optimize the lifetime of equipment and facilities. This label provides a comprehensive assurance of a product's eco-friendly credentials. Customers can easily access the Environmental Product Declaration or Life Cycle Assessment of all ABB products carrying the Eco-Solutions label. Using them as external validation confirms the product's environmental impact. Throughout this webinar, our team have identified important performance power characteristics of the HiPerGuard MV UPS. Whether utilising a single 2.5 MVA power block for an industrial load or building out multiple power trains for large multi-megawatt data centre facility, the HiPerGuard MV UPS truly is the backbone to securing facility-wide power stability and uninterruptible power. This graphic demonstrates a 4-to-make-3 distributed redundant system protecting a load of 30 megawatt with the usage of 16 2.5 megawatt medium voltage UPS systems. Demand for processing and storing data is increasing exponentially. Data center providers are needing to adapt to new capacity requirements due to emerging technologies such as AI, increased cloud services and gaming, whilst also trying to adhere to sustainability ambitions of net zero reduction in their carbon footprint. ABB's HiPerGuard Medium-Voltage UPS tackles these challenges, providing continuous high-capacity power for critical industries, including data centres. It is designed to protect entire facilities whilst reducing carbon emissions by several hundred tonnes. As has been demonstrated throughout this webinar, significant advantages can be gained while operating protection at the medium voltage level. Class 1 protection can be maintained whilst minimising distribution losses and enabling a significant reduction in copper use. ABB's extensive capabilities in delivering multi-megawatt critical facility protection ensures your organisation can achieve its sustainability ambitions at scale. The HiPerGuard MV-UPS provides the opportunity to participate in grid support services, including demand response, contributing to overall grid stability and reliability. This provides a means for additional revenue streams for the facility owner to meet business sustainability objectives. Let's write the future of safe, smart and sustainable electrification together with ABB's HiPerGuard Medium-Voltage UPS. Thank you for joining this webinar on next generation power protection for data centres.